As the session chair of the first Keynote session, it is a really great honor for me to present our first Keynote speaker. He's Dr. James Hansen, adjunct professor at Columbia University's Earth Institute. He's a former director of the NASA Goddard Institute for Space Studies. And already in 1981, Dr. Hansen published a paper in Science on the climate impact of increasing atmospheric carbon dioxide, where he and co-authors predicted that the shifting of climatic zones will happen and the erosion of the West Antarctic ice sheet, and it will follow a general rise in the sea level. And then realizing that the danger of this global scale experiment with the climate that we're doing, Dr. Hansen was one of the first to really sound the alarm and raise awareness of the general to the general public, and he's continued to push these questions for more than 3 decades, and I think that's really commendable. So let's give a warm welcome to James Hansen.
Thank you. Good morning, and thanks to Anders for inviting me. Let's see, do I move the slides? Let me try pushing a button. Okay. So the title is, I think, exactly what Anders asked me to talk about. I should say I'm skeptical about how big a role negative emissions can play, but I'm open-minded, so you can persuade me. I think there's a big moral issue about this, and that is we have to be very careful not to leave the impression to policymakers and the public that we're going to provide them a get-out-of-jail-free card, because maybe you can, I hope that you're successful in finding economic ways to extract carbon from the atmosphere, but the sensible thing to do at this point, and I'm glad that Eva mentioned that in her remarks, we have to inform the public and the policymakers that we have to begin to reduce emissions very rapidly, and we've been saying that now for a number of years, and we have not been doing it. The emissions just keep going up. They actually have to go the other direction. So that's a moral issue to keep in mind. And I want to raise a different moral issue later in my talk. Let's see if I can move these. Yeah. Okay. So the situation is that we do have a global crisis, but yet it's not obvious. I mean, look how nice the weather is. So the public doesn't really understand. And that's because of the inertia of the system. We're pressing the climate system by changing the composition of the atmosphere, but it doesn't respond quickly because of the deep ocean and the thick ice sheets. They don't respond quickly. So there's more warming that's in the pipeline. Even if we stabilized atmospheric composition today, there's more warming in the system. We know this very well. We can measure the planet's energy balance, and there's more energy coming in than going out. So we're going to get additional warming over the next few decades. And we live on a planet in which the climate is characterized by amplifying feedbacks. And again, we know this very well. We've looked at the history of the Earth over the glacial and interglacial variations, and very small forcings end up causing large climate changes because of the dominance of amplifying feedbacks. As you melt the ice sheets, you expose dark area, and as the planet gets warmer, the soil and the ocean give more methane and nitrous oxide and CO2 to the atmosphere. So this is a recipe for potential disaster if we don't understand it and make effective policies. So the warming is already more than 1 degree Celsius, most of it in the last few decades, during which time the greenhouse gases have increased rapidly. And this has already raised global temperature well outside the range of the Holocene, and approximately to the temperature of the Eemian, the interglacial period 120,000 years ago, when the Earth was warmer than today, or actually now today's temperature has just approximately matched the Eemian temperature. And we know that when the planet gets warmer, and we've seen many cycles of this, as the planet gets warmer, ice melts, sea level goes up. During the Eemian, sea level was 6 to 9 meters, 20 to 30 feet higher than today. It takes time for the ice sheets to respond, but the eventual consequences, if you just look at the map of the large cities in the world, you see that more than half of them are located on coastlines. So multi-meter sea level rise would cause most of these cities to become dysfunctional. So the consequences are potentially enormous. How long it will take for the ice sheets to respond to a warmer climate is uncertain. We argue in this paper, Ice Melt, Sea Level Rise, and Superstorms, that if we stay on business as usual, the response time for multi-meter sea level rise is probably between 50 and 150 years. So at any rate, it's faster than the timescale for the system to naturally take up the excess CO2. And the second irreversible effect of large climate change will be the extermination of species, which occurs in combination with all the other stresses that we're putting on the different species. We have, when we're now shifting, a given isotherm is moving poleward at a rate of several kilometers a year. And eventually, when that shift becomes large enough, it becomes a significant factor in causing the extermination of species. Potentially, a significant fraction of the species on the planet could be driven to extinction. For example, coral reefs are stressed by both the increasing ocean temperature and acidification and other human-made stresses, which we're now losing a significant amount of coral reefs each year. And there's an enormous number of species associated with those coral reefs. So those are irreversible potential effects. In addition, there are local and regional changes in extreme events. This chart shows the natural variability of a seasonal mean temperature, specifically in the summer in the northern hemisphere land areas. Last century, it formed a nice bell curve about the average temperatures of that time period. But now, with that relative to that same climatology, the temperatures have shifted significantly, such that the extreme warm events have become noticeably more frequent. This depends upon the season and upon the location. So both the United States and Western Europe, the shifts are relatively moderate. If you're as old as I am, you may notice that there's been some change in climate, but especially in the summer, where the shift compared to the unit of measure is the standard deviation. And in the winter, the natural variability is larger, so it's a little harder to see the change. But if you look at the subtropics in the summer, the Southwest United States or the Mediterranean and Middle East region, the summer, the shift is more than 2 standard deviations. So every summer is now warmer than it was last century. And in the tropics, for example, in Southeast Asia, all 4 seasons have a shift of a couple of standard deviations. So, and it's becoming uncomfortably warm in the summer, in the subtropics, and in the tropics. And it affects most of the jobs, more than half of the jobs are outdoor jobs, agriculture or construction. It is becoming difficult to work in these conditions, and it increases the pressure for migration from the lower latitudes to cooler latitudes. So one of the impacts of this shifting bell curves is an increase in climate extremes. And also, as I mentioned, in just the ability to live and work outdoors in the subtropics in the summer and the tropics. This is a bit of an exaggeration. We haven't quite reached the point of having only hot, dry seasons and flooding. And this is also a bit of an exaggeration, but we're actually very close to the point of handing young people a situation in which large sea level rise will be out of their control. It's not happening, next decade, but we may very well hand young people a situation in which they cannot avoid the consequences. And so that's one of the big potential injustices of what we're doing to the atmosphere. A second one is of the north relative to the south, because we in the north are burning, are the ones getting the benefits of burning the fossil fuels, but we're leaving the worst consequences for parts of the world that have done very little to cause the problem. And of course, humans are the entire source of the problem, and the other species all suffer. And we're not significantly addressing the problem. The emissions after the Kyoto Protocol actually went up faster than they did before. So you can't solve the problem with half measures. Places now, although, as I mentioned, we in the north caused most of the problem, but now the rest of the world wants to follow the path that we did to increase the standard of living, and they're doing it the same way that we did, getting most of their energy by burning fossil fuels. As we discuss in the paper, Young People's Burden, and by the way, on this paper and the other one that I mentioned, and there was a third one in PLOS 1 a couple of years before that, I'm very grateful that other members of the scientific community have cooperated in helping us produce papers which we can use for lawsuits against the U.S. government in particular, and I think also against the fossil fuel industry in the near future, to try to pressure them to take the actions that are needed for the sake of young people and future generations. So in this paper, though the IPCC scenarios are complicated, so we decided to do some simple scenarios in which we look at plus 2% per year continued emissions and constant emissions from 2020, or reducing emissions 3% or 6% a year. And you can do this with fairly simple, straightforward models so it's not too complicated to understand. So this was with a model with 3-degree sensitivity for doubled CO2, which is in the middle of the range of uncertainty and consistent with paleoclimate data. And what you see is that if you would begin to reduce emissions even a few % per year, you could keep global warming below 1.5 degrees. The problem is, of course, that we're not reducing emissions. But if you have even constant emissions, you're going to end up with global warming, which would have tremendous consequences, without any doubt, for young people. So the basic problem is that to the user, fossil fuels seem to be the cheapest energy. But that's because they don't include their cost to society. So the simple solution is to have a rising tax or fee on carbon emissions, which I'd argue should be across the board. And of course, you do need regulations, and we do need technology development. But these would be spurred by a rising carbon price. And that would also, I think, should be the basis for how you choose among negative emissions. That simply is an alternative for just part of that same market mechanism. And I argue that the fee should be collected at the domestic mines and ports of entry, and that the money should be distributed to the public, so that you're then it actually spurs the economy, and so it doesn't need to cost anything if you do this in a simple, honest way. And I don't see how you can have an international mechanism that will work other than by means of an across-the-board carbon fee or carbon tax, because we're still pushing this concept of cap and trade. But what's the cap on India? You know, what's the cap? You can't, you can ask each country to have a cap, but the simple way to do this, and I think the only way that it's going to work, is an across-the-board carbon fee or carbon tax. And the countries that do it would put a border duty on products from countries that don't have a carbon fee, and that's an enormous incentive for the other countries to have their own carbon fee so they can collect the money themselves. And until we realize that and do it, I don't see us solving the problem. We have been able to, the developed world has leveled out its emissions, and perhaps will even get small reductions. Although even part of that is the fact that we've transferred production of materials to the developing world. So our actual carbon footprint has not been going down even in the developed world. And the biggest emitters now, among the major emitters, are United States and Canada and Australia are the biggest annual emitter. But if you look at cumulative emissions, then the United Kingdom and Germany are about the same as the United States. We all have a big moral obligation to address this problem in a way that will actually work. And so the other moral issue that I want to raise relates to my oldest grandson, Connor, who was a big Indiana Jones fan. And I was amazed at the age of 10 years, he correctly identified the two most important factors. One of them being about this time dependence. You know, unless we can figure out a time machine that actually works, there's going to be no way for young people to go back and fix the problem if we don't fix it. And the other thing he said is, oh, grown-ups are very scared of nuclear power. But we know that using fossil fuels is not safe. It's very dangerous. I think those are the two key points. And I want to show 5 minutes of a press conference that Michael Schellenberger and I gave at the last COP. And so I need to be able to hit, how do I move? Okay, I go here. It should show up.
My guests with me today, Michael Schellenberger, who's president
Oops, I did something wrong.
of Environmental Progress and co-founder of Breakthrough Institute, and Dr. James Hansen, former director of NASA's Goddard Institute for Space Studies and current director of the Climate Science Awareness and Solutions Program at Columbia University's Earth Institute. Today's show, Nuclear Power, Are Renewables Enough? This is one of the elephants in the room. Michael, take it away.
Thank you. Thanks for the introduction, Stuart, and Jim, thanks for inviting me out. My own background is as an advocate of renewable energy. I was co-founder of the Apollo Alliance, which pushed for a big investment by the U.S. government into renewables. We successfully persuaded President Obama to put about $90 billion in a clean energy stimulus. Starting in 2009, about $150 billion was spent by the United States over the last 10 years. And you can see clean energy has grown in absolute terms. These are the four main low-carbon energy sources. Hydro is the largest source of clean energy globally, then nuclear, then wind and solar. But the problem is that the share of electricity globally coming from clean energy has declined 4.5%. And that's mostly because poor countries are moving to fossil fuels, which is understandable. They need to develop, as the gentleman from Egypt said earlier. However, part of the problem is the decline in nuclear power. Nuclear has declined about 7% from its peak in the mid-1990s. It's declined in absolute terms since the mid-2000s, 5 years before Fukushima. And while people talk a lot about solar and wind, it hasn't even made up the difference of the loss of nuclear. What about the investment? Renewables received 114 times more in subsidies than nuclear per unit of energy generated in 2016. That's just in the United States. We just did a study that was covered in the New York Times today that shows that we've spent about the same on solar and wind over the last 10 years that we spent on nuclear over the last 54, the data from Bloomberg New Energy Finance. So you can see here in the blue and the green is how much nuclear or hydro was added in a given 10-year period, just so we can get a sense of how quickly can you scale these. Red and yellow were solar and wind, so you can see that you're just able to add a lot more zero-carbon power in a decadal period of time from nuclear and hydro. Renewables just require a lot of materials. You can see that solar just requires a lot more steel, glass, cement. And that's because the fuels, renewables fuels, sunlight, wind, water, are just energy dilute. So you have to spread collectors over a much larger physical space to aggregate those flows into usable electricity. So here's another way to look at it. The amount of materials that you're required to produce power from renewables is inversely related to the energy return on energy invested, another very good German study for the EROI numbers. And as a consequence, solar panels end up creating 300 times more toxic waste than nuclear does per unit of energy, just because of that huge material throughput. And unlike nuclear waste, which is safely contained in casks and never harms anybody, solar waste joins the electronic waste stream, and it's usually taken apart in poor communities where children are exposed to cadmium, chromium, lead, and other toxins that never decline in toxicity because they're elements. What about Chernobyl? Everybody worries about the accidents. I changed my mind on nuclear in part because I just finally sat down and read the United Nations reports on Chernobyl. So this is what they say. Don't take my word for it, just look it up afterwards. 28 deaths from acute radiation syndrome. Those are the firefighters that got real close to the fire, an unshielded, uncontained reactor. 15 deaths from thyroid cancer over the last 25 years. Thyroid cancer, nobody wants to get cancer, but if you have to get cancer, that would be the one you'd want to get because the mortality rates are so low. It's really nobody should die from it because it's treatable, completely treatable. UN estimates there will be 1% deaths, that would be 160 deaths over a 75-year, 100-year time span after the accident. Despite what you might read in the tabloids, no effect on fertility malformations or infant mortality, no effect on pregnancies, no heritable effects, no proven increase in any other cancer, including among the guys that put the reactor fire out. Again, don't take my word for it, just look it up. Fukushima, no deaths from radiation, 1,500 deaths from anti-nuclear radiophobia. So all of the fear-mongering that's done on nuclear causes real harm. 15,000 people killed by the tsunami. Unlikely to be any increase in thyroid cancer, no impact on adverse pregnancy. Maybe there's a gigantic cover-up of the truth about these accidents, a big conspiracy. It would require thousands of scientists involved in a conspiracy at the world's best universities. So you might ask yourself, how probable is that that's occurring? Living in a big city actually increases your risk of death more than putting out the Chernobyl fire. This is from the British Journal of Public Health. Just air pollution turns out to be pretty deadly if you live with a smoker. What about accidents? The worst accidents from renewable energy. 170,000 people killed instantly when the Banqiao Dam collapsed in China. What about natural gas? That's clean, except for when it explodes, as it tends to do. Even here in Germany, it explodes and kills people. What does the World Health Organization say? 7 million people die annually from air pollution. This leads to a really uncomfortable truth for people that are anti-nuclear, which is that nuclear is the safest way to make reliable power, and that means that whenever you're doing nuclear, you're literally saving millions of lives. James Hansen has done a study. He's found that nuclear has actually saved almost 2 million lives to date just by preventing the burning of fossil fuels. That doesn't account for any impact on the climate. That's just air pollution. World Wildlife Fund did a study. How many people is German pollution killing? About 2,500 a year. 2,500 a year people being killed from premature deaths from particulate matter, mostly PM 2.5. When I was a child, I used to think that energy and weapons were somehow related. Well, how much more proof do you need that they're not than the fact that North Korea wanted nuclear energy, it was denied nuclear energy, and it got a bomb. South Korea got nuclear energy, and like all countries that get nuclear energy, it had to agree to not get a weapon, and it doesn't have a weapon. Nothing prevents the spread of nuclear weapons more than nuclear power. We have 60 years of data on this. There's no advanced calculations required. It's just the truth of the matter. If you want to be part of nuclear energy, you must agree not to get a weapon. A growing number of us have changed our minds because of our concern about the climate crisis. The anti-nuclear movement to which I once belonged has misled the world about the impact of radiation on human health. George Monbiot wrote less than a month after Fukushima, when it was already clear that nobody would die from the radiation from that reactor. So where do we stand now? The anti-nuclear movement has succeeded in frightening people about the reality of these different energy sources. We could end up losing twice as much nuclear as we gained by 2030. Germany stands as a stark warning to the world. It's very ironic that Germany is the one hosting this conference. Its emissions going up, and the leaders here blithely reassuring everybody that it can be powered on renewables, even though the last several years prove that it can't. I'll just leave you with this quote from Sting, who changed his mind and gave an interview to Rolling Stone last year. If we're going to tackle global warming, nuclear is the only way you can create massive amounts of power. Thank you very much.
All of the cases of rapid introduction of carbon-free energy in the past have been via the introduction of nuclear power. However, this does require, so for example, Sweden, over a decade period, added, I think they built 10 or 12 nuclear power plants, a couple of them in Finland actually, but they first had to decide what they're going to do this and then choose a design, and so there's a preliminary period in which you need to have done the R&D to have the technology that you want. And nobody would recommend building these old nuclear reactors, 50-year-old technology. So we should have been working on technologies for much improved, safer, even though nuclear power has historic record, is very safe compared to the 10,000 people a day that die from fossil fuel pollution. It's more than died in the history from nuclear power. So, but we should have been doing the R&D to have the potential so that young people have an option. Just as your research is appropriate, in my opinion, even though I'm very skeptical. And we have to be very careful about correctly informing the public and policymakers about the potential. But you should be doing the R&D to figure out what is the potential. And we should have done the same thing with advanced nuclear power. But it's so much easier for political leaders to take advantage of this fear, this phobia that has been created and get some votes. Anyway, I think that is for example, we knew in the 1960s that there were better ways to develop nuclear technology than the light water reactors, but the military wanted the light water reactors, so we didn't develop alternatives. But we should do that R&D for the sake of giving young people an option. So what's actually happening? The greenhouse gas, this is the annual increase in the greenhouse gas climate forcing. And what you see is that we're not actually making progress. If we just go back the last few years, the RCP 2.6 scenario of IPCC is the scenario that would keep global warming at about 1.5 degrees Celsius. But already in just the last few years, there's a gap that's developed between the real world and RCP 2.6. So the gap in 2015, you could close that gap by extracting CO2 from the atmosphere, CO2 providing 80% of this greenhouse gas forcing. But if you would have to take about 2 ppm of CO2 out of the atmosphere, which is 4 gigatons of carbon, just to make up for the gap in the single year, 2015. So if the extraction cost is $100 a ton, that's $400 billion just to close that gap for 1 year. Now we have a look at the next year. Well, the gap got even bigger. Now it would be $500 billion just for this 1 year. So you've got to get a really cheap number for your extraction cost if you want to make up for this. It makes more sense to begin to reduce our emissions so we leave a solvable problem for young people. If you look at CO2, the graph, CO2 keeps going up. Not only does it keep going up, but the rate of growth is increasing. It's now smoothing over these tropical, the temperature oscillations. We see that the growth rate is now 2.5 ppm per year, while we actually have to go in the other direction. Methane, its growth rate, again, looking at the graph on the right, its growth rate had actually fallen to about 0, but now it's increasing again. That's probably in part due to the technology of fracking, which increases the emissions during fossil fuel mining, and also just the feedback. The planet is getting warmer, and there's feedback associated with that. Nitrous oxide is also continuing to increase, and even its growth rate is maybe flat, but well, I think that I will stop at this point and allow Q&A if that's okay.